Welcome! Today is February 1st, Monday. As you guys can see on my Canvas page, I'm not here. Since I am at home, you can probably hear. And I do apologize if this bothers you, but I will probably be sniffling a little bit during this video. Okay, you should have completed your warm-up already, or you're watching this video. We're going to go through the Desmos. And then you're going to have some work time. So your warm-up was to simplify some radicals, and then let's check your answers on slide 2. If you have questions about how I got this, make sure you email me. All right. Let's go ahead and get started with our objective for today. It is, I can find the surface area of prisms and cylinders using nets. So you guys will notice that one of the standards for geometry is to create a net for a given 3D dimensional solid and to describe the 3-dimensional solid that can be made from a given net or pattern. So that is why we are talking about nets today, even though we have formulas to find both of these things. Okay. Take a moment and pause the video to identify the shapes below. Do you remember what each shape is called? Okay, welcome back. Let's see if you got the right answer. So the first shape was rectangular prism, the second shape was triangular prism, and the third shape was pentagonal prism. Take a moment right now. Pause the video, and based on your observations of these 3 shapes, what do you think that the properties of a prism is? Go ahead and write it here and press share with class when you're done, and you will be able to see your classmates' answers. Okay. You guys can read what you guys came up with. What about this shape here? What's this shape called? Pause the video, write your answer. Did you answer cylinder? Because that's what it's called. Alright, right now, what do you think? Is a cylinder considered a prism? Explain why or why not. So you'll press yes or no, and there'll be a box for you to explain your thinking. Okay. So here are some vocabulary notes that I want you to write in your notebook. A prism is a 3-dimensional solid made of plane figures, 2 of which are congruent parallel bases. So in this shapes here, you'll notice how both of them have the same base. Well, not the same base, but they have 2 shapes that are the same. Congruent and parallel, which means that they never cross. So the first shape here is a pentagonal prism, and the second shape is a triangular prism. So it's named after the bases. So with a cylinder, even though we have a congruent parallel bases, the side of it, which is curved, isn't in one plane. So it's not considered a prism, even though we treat it very similar to a prism. Right, some vocabulary terms are bases, so that's what I was just talking about. The bases are the faces of a prism that are congruent and parallel. It's really important that you were able to distinguish the bases and the edges and faces of a prism, because that comes in handy when we talk about the formula that we use in volume and surface area. So we have lateral faces. Those are the faces of the prism that connect the 2 bases. So all of these are lateral faces. So a pentagonal prism has 5 faces. A triangular prism only has 3 faces. And then lateral edges. So the edges are where the faces meet. Okay, go ahead and write these down if you haven't already. Pause the video if you need more time. Okay, what do you remember about finding the surface area of a rectangular prism? Do you think that you could find it? Go ahead and try. Pause the video and try. Alright, let's see what you guys came up with. Now, in 7th grade math, which I believe is one of the grades that you guys skipped, we talk a lot about nets for rectangular prisms. So we would draw out what that shape would look like unfolded. So in this case, we have our 4 faces, and then we have our base. Our bases, so it kind of looks like a, I don't know, a robot? Or a bed that has the pillows off to the side. Not sure. So anyways, so this would be like 3 and 4, and then our faces are 6, right? And with surface area, we're finding the area of all of the surfaces. So if you were to be packaging up a gift, we would figure out how much wrapping paper we would need to cover the shape. So basically we want to find the area of all of these shapes. So these are all rectangles, which should come in handy because the area of one rectangle is length times width. So really you're going to have to add all of these up. So you have 6 different types, but you have the faces that are different. So we have 2 of these that are 4 times 3. So for surface area, we're going to find actually 2, and then 4 times 3. And then plus 2 and 3, let's see, different color, 3 and 6. So that would be 3 and 6. That's what this shape is. There's going to be 2 of them. And then we have another shape, one more, is going to be our 4 and 6. So that would be the other 2. So 2 times 4 times 6. So it's kind of helpful when you draw it out to be able to distinguish which ones are which. So then if you were to solve it, let me go ahead and do some quick calculations here. So here then the surface area of the shape is 108 centimeters squared because we're talking about area. So this is a long process. There's actually a shorter way to do this, which we'll talk about in a little bit. All right. Before we move on though, what I want you guys to kind of think about on slide 10 is compare and contrast the surface area and volume with any given prism. Like what can you kind of come up with? I want you to pause the video. I want you to write this out. I'm going to look at what you guys come up with, and we're going to talk about it more on Wednesday when I come back, and when we start talking about volume here. So pause the video, write out your thoughts. What do you remember about surface area? What do you remember about volume? What's different between the two? What's similar between the two? Okay, let's talk about surface area. So we have a couple of slides here, which are going to be your notes, which you will want to make sure that you are writing down your notes in your notebook. Okay, so here we have an image, and it talks about lateral area and surface areas of a prism. And we can use a net. So these are the 2 different aspects. So this here, surface area equals LA plus 2B is actually kind of what we're going to use for prisms to find our surface area. And this will work for a lot of different shapes because each component here stands for something that you need to remember. So lateral area, or LA in our surface area formula here, refers to the area of the lateral faces altogether. So And that piece of it is pH, and pH stands for perimeter times height. So you'll notice in purple, the perimeter is talking about the perimeter of the base. So even though it's on the outside of the faces, we're actually talking about the perimeter of the base here of this shape, which also corresponds to the top edges of the lateral faces. So you would add all of those together to get our P. And then our height, of course, is the height between the two bases. And that's how you find your lateral area. So we could actually, instead of writing LA, we could write PH. But you need to remember that the P stands for perimeter of the base. So perimeter of the base. All right, and then 2B stands for 2 times the area of the base. So great. So you have to find the perimeter and the area of the base to be able to find that. All right, so I have here another image. You guys don't have to write this down on this image on slide 13, but I thought I would give you some information if this helps you think about it a little bit differently, or if it makes a little bit more sense than the other image. So this one says the lateral area of a right prism is the product of the perimeter of the base and the height of the prism. And then the surface area of a right prism is the sum of the lateral area and the area of the two bases. So instead of writing like this whole like SA equals 2 times length times width plus 2 times width times height plus 2 times width times length, then you get just this small equation. Actually, this isn't actually the one that we're going to use. This is the one that we're going to use. So I have the surface area is equal to 2B plus PH, where B, capital B, is equal to the area of the base, and P equals perimeter of the base, and H is the height of the solid, so of the shape. Go ahead and write this down. You will want it. Actually, you have a piece of paper where you're going to need to write it down. So, on your piece of paper that the guest teacher passed out, you'll want to write your notes on there. If you are at home, you will want to write your notes on a separate piece of paper. This will be a little bit harder for you to write down because I don't give you a graphic organizer, but let's go back and look at what you need to fill out there. So the surface area to capital B plus PH is what you're going to write here, where the big B is equal to the base, the area of the base. P stands for perimeter of the base, and H stands for the height of the solid. Okay. We also have an area for the surface of a cylinder. The surface area of a cylinder, we can still use this formula, but since a cylinder has the basis of a circle, then you're going to start talking about pi and pi r squared. So I'm just going to give you the formula, even though that one works. So here on slide 15 is where I kind of talk about the transition from 2b plus ph to 2 pi r squared plus 2 pi r h. So we're talking about 2 times the base of the shape. So in this case, a cylinder, not a cylinder, sorry, a circle. The area of the base, the area of a circle is pi r squared. So you have 2 of those. And then P times H, where P is the perimeter of the base. Well, perimeter of a circle is called the circumference, which the formula for circumference is 2 pi r, and then we just multiply it by the h. So if you remember that whole 2 pi r squared, great. If you forget it for any chance and you remember the 2b plus ph, then you can kind of get to the official surface area. All right, I did want to show you guys, I did look up the geometry reference sheet that you would get on your not this year's test. This would be in high school. On iStep or whatever they have there. I'm not sure exactly what test you would get in high school, but it does give you the surface area formula for cylinders and for rectangular solid is what they call it. This is the old one, but it just still means the same thing. So they do give it to you, which is very helpful. All right, let's move on. All right, so if you are at home, you will want to do this on paper. Okay, so if you are at school, you will have this on paper that you can write out the work here. If you're at home, I have it on Desmos. So if you're at school, I think it would be easier for you to do it on paper, but if you wanted to do it on Desmos too, that's fine with me. Okay, so we have our first shape here. What is the name of that shape? Write it in this box. Okay, the name of this shape is indeed rectangular prism. We name this out, oh, this is not going to be fun. Okay. It's going to look weird, but I get what you're saying. Technically, this is a right rectangular prism because it has a right angle from the base to the sides, the lateral faces. Okay, now you're going to want to sketch out a net of what this looks like. And I've already given you guys an example of this, so I'm not going to have you guys do that. I'm sorry, you are going to have to do it. I'm not going to show you what it looks like. Okay, and then I want you to use that formula to find the surface area. So remember, it's 2 base, the area of the base, plus pH, perimeter of the base times height. Go ahead and find it. You will want to show your work on paper, and you'll submit this at the end of class, so make sure that you have it neat so that I can see it. Okay, once you finish this, if you haven't finished it, obviously pause it. You will have 4 different shapes to do for this. So you have this shape on slide 19. You'll have this shape on slide 20. And one more shape on slide 21. I want you guys to work on those. Then you are going to submit a picture of your work from Desmos to Canvas. And then you're going to work on 2 IXL topics. The first is T.2, surface area of prisms and cylinders, and T.1, which is the surface area and volume of rectangular prisms. So this is review, but I'm not sure how much you guys have done with this in the past. This is a 7th grade, it's geometry IXL, but it's a 7th grade standard. If you finish early, you will have these algebra topics. Okay, I want you to pause this video, complete slides 18, 19, 20, and 21. Then I want you to check your answers with me. I'm going to show you the answers just one moment. Okay, so do them first and then check your answers. Okay, here is my work for how I found the surface area of the right rectangular prism, which was 1,726 centimeters squared. Make sure that you are aware of the squared, since we're talking about area, even though it's surface area. Okay, pause the video if you want to take a look at my work. And then go to the next slide so you can see, not the next slide, sorry. Just continue watching the video to see the answers for the next slides. All right, welcome.
I kind of have my work over here. I had to use the Pythagorean theorem to get the hypotenuse for the perimeter of my base here. So I ended up with 8 plus 4 root 2. And I left it as a radical just to get practice with radicals. And then I substituted it into my formula. And here, when I was multiplying this radical for perimeter times the height, I had to distribute. If you guys used a calculator, that's fine. You should have gotten my similar answer here of 125.25 inches squared. I just wanted to have you guys see some practice with radicals there. If you didn't use the radical, that's totally fine. Let's try the next one. Okay, this shape was a cylinder. Here is the formula I used. You guys will notice that I left it in terms of pi until the very end. That makes my answer more exact. So not obviously perfect, but it's the closest approximation of my 301.59 inches squared, or 96 pi. I will accept either way. I did not specify which way I wanted you guys to do. So there you go. One more shape. Alright, and last but not least, our trapezoidal prism. Here I have a net. Obviously, you could have put it together a little bit differently. I chose to separate the bases out, although they don't really look like it at all. It is what it is, though. So, just kind of a guess. My net is not perfect. But my answer is 72.8 inches squared. So what I did here is I took my base, which I used the formula 1/2 height times base 1 plus base 2 to find the area of a base of 14.3. And then the perimeter I found to be 17. Then I substituted into the formula to get 72.8 inches squared. Those are my only examples I have for you guys after your practice round. So now you can go ahead and go to the IXL topics. I will see you guys on Wednesday.